Hello, year 11. We've got 15D, the quotient rule, coming next. We just finished doing the product rule. So what you'll notice is if we can identify a function as a product, we wound up multiplying u prime times v plus v prime times u, and they were added together. Notice that you have the same order, so u prime v and v prime u, with the quotient rule. So if you identify that you have a function that is the quotient of two other functions, we can separate them out, identify which one is u and which one is v, and we can lay out our working for u dashed and v dashed as well. But the two differences is that you are now going to be subtracting the two products and dividing by the original second function or derivative function, or sorry, denominator function squared. So you do have two differences, but if you remember the order of u prime v and v prime u, you keep that same order for the quotient rule, but you subtract, and then you also divide by v squared. Remember, with quotient rule, subtraction will make a difference, so you've got to make sure you're subtracting in the correct order, whereas with the product rule, you're adding, it really doesn't matter which of these two products you wind up adding first. However, if you remember the order, then it would be the same for both product and quotient. So let's go ahead and identify our u in this first example. So y is equal to 1 plus 3x. We're going to say our numerator, 1 plus 3x, is our u. So we can take the derivative of u as 3. We can do the same for our denominator, our v, as 2 minus x, which makes the derivative of v negative 1. So now when we wind up finding our derivative of y, we will take, again, u prime, so that's blue, 3, multiplied by the original v, which is 2 minus x, and we'll wind up subtracting that with v prime, so that's negative 1, multiplied by original u, which is 1 plus 3x. Oops. And we will wind up dividing by the original v, so your denominator, squared. So our original v, oops, there we go, is 2 minus x and squared. All right, so let's just make sure we have everything correct. U prime times v minus v prime times u divided by v squared. So let's go ahead and clean this up. Now with the quotient rule, we want to make sure that we actually have one denominator and we simplify our numerator. So for this one, we'll wind up expanding 3 by 2, so 6 minus 3x. Careful with the subtraction. So I'm going to say subtract, and I'm going to put brackets here so I can expand the negative 1 to the 1 plus 3x. Or I can say negative times negative makes this positive 1, and then expand positive 1. So again, just make sure you're not missing any of the symbols that we have here. So I'm going to keep my minus, this minus here, just for a moment. So negative 1 times 1 is negative 1. And then negative 1 times 3x is negative 3x. So that, oops, hard bracket, there we go. And then we'll keep the 2 minus x squared. Let's go ahead and simplify that again. So 6 minus 3x plus 1 plus 3x over the same denominator of 2 minus x squared. And then we'll wind up simplifying that again. So negative 3x and 3x will cancel out. So 6 plus 1 is 7. Divided by the 2 minus x quantity squared. So our derivative, y dashed, is 7 divided by 2 minus x quantity squared. Let's go ahead and take a look at another example. So for the second one, again, we'll identify, let's see, we use blue. Let's use blue for this one. So our u as 3x plus 2. We're going to set out all of our working ahead of time. So our derivative is 3. And then for v, we have the square root of x, which again we will think of as x to the 1/2 power. So that when we take the derivative, we get 1/2 x to the negative 1/2, and we'll rewrite that as 1 divided by 2 square root of x. Let's go ahead and substitute in. So f derivative, u prime v, so 3 multiplied by square root of x minus v prime, so 1 divided by 2 root x, multiplied by u, so 3x plus 2. Now, all of this is going to be divided by v squared, which is the square root of x squared. Right now, you have the derivative of the function f. However, we have a fraction and another fraction. We never want to leave a fraction within a fraction. So we want to simplify down as far as we can, so we at least have just one fraction. Then it's ready for any other further steps that we might need to do with it. So our first thing is going to be to ignore this denominator for a moment and take a look at just the numerator so we can try to find a common denominator for the numerator. So what we've got here is the 2 times square root of x. We're going to wind up using that as our common denominator, which means we're going to have to multiply this left term by 2 root x over 2 root x. So we can find a common denominator there. So we will wind up with, let's see, so 2 times 3 makes 6. Root x times root x is now just going to be x minus 1 times 3x plus 2, so that was going to, the negative needs to expand to both terms as well. So I get negative 3x and negative 2. So my numerator now is 2 times 3, 6, root x times root x is just x. The negative expands, negative 1 really, expands to the 3x and the 2. So now we have a common denominator of 2 times square root of x. Now notice this denominator here of the whole function, we have the square root of x squared. So the square root and the square will cancel out. So really you're just dividing by x. And think back to how we divide fractions. A fraction divided by a fraction is the first fraction times the reciprocal of the second fraction. So if you think of the second fraction as x over 1, we are actually going to multiply that by the reciprocal. So this x winds up joining this denominator. So I wind up with 6x minus 3x. Let's simplify that to just 3x minus 2. And then my denominator would be 2. I now have the x from this denominator and the square root of x. All right, so I have now simplified this huge, massive quotient rule just to 3x minus 2 over 2 times x root x. And that is a simplified version of my function, of the derivative of my function. And that way it's ready for me to do something else with it when it's in this simplified form. All right, guys, so for example 2, we're going to leave you guys in charge of identifying your u and your v, apply the quotient rule, and we'll check this next class. Have a great night.